Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Inside every automated factory, thousands of actions happen every second. A sensor detects a bottle. A PLC starts a motor. A VFD changes speed. A temperature transmitter sends a value. A valve opens exactly 42%. An HMI displays the alarm before the operator even reaches the machine. But here's the real question. How do all these machines talk to each other? Not in human language, not with voice, not with simple electrical signals alone. They communicate through industrial protocols, structured digital languages designed for machines. And among the most important names in this world are Modbus and Profibus. These protocols may look invisible, but without them, a modern factory becomes blind, silent, and disconnected. Before PLCs, factories were controlled by massive relay panels. Each input, output, interlock, timer, and sequence required physical wiring. If the process changed, engineers had to rewire the panel. Then came a revolution. In 1968, Dick Morley invented the Modicon 084 PLC. The PLC replaced many hardwired relay circuits with logic stored in memory. But as factories became larger, another problem appeared. A PLC could control a machine, but how would it exchange data with remote instruments? Running one cable for every single signal was expensive, messy, and difficult to maintain. So engineers needed a new idea: send many signals through one communication cable. This idea gave birth to industrial communication protocols. A PLC communication protocol is like a grammar book for machines. It defines how data is formatted, who sends the message, who receives the message, what address the data belongs to, how errors are checked, how fast the exchange happens. A protocol tells machines how to speak, how to listen, and how to understand each other. Without a protocol, a PLC may send a value of 1,500, but the drive may not know what it means. With a protocol, the message becomes meaningful. That is where Modbus becomes extremely important. Modbus was developed by Modicon in 1979 for process data exchange. It was designed as an application layer protocol and can be used over serial and Ethernet systems. This is the beauty of Modbus. It is simple, open, and easy to implement. That is why it is still used in utilities, water plants, energy systems, and SCADA networks. Modbus uses function codes, and Modbus TCP commonly uses reserved TCP port 502. Now let us decode this clearly. In classic Modbus communication, one device asks and another device answers. Traditionally, we call them master and slave, or in modern terms, client and server. The master or client initiates the question. The slave or server replies. The PLC asks, what is the temperature value stored in register 30001? The temperature controller replies, the value is 72.5 degrees Celsius. This is how a digital conversation becomes a physical action. To understand Modbus, remember four main data areas. The data model includes discrete inputs and coils, which are single-bit data areas. Then we have input registers and holding registers, which store 16-bit words. Now simplify it. A bit means on or off. A register usually stores a number. This is why Modbus is popular. It converts industrial signals into a simple digital memory map. A Modbus message contains a function code, which tells the device what to do. Function codes define actions like reading or writing bits in 16-bit registers. A SCADA system can start a pump by sending a write single-coil function code. In a water plant, one screen can monitor everything through structured Modbus communication. Modbus RTU is widely used over serial communication, especially RS-485. It is compact and efficient. There is also Modbus ASCII for readability and Modbus TCP for communication over Ethernet. Modbus TCP is common where PLCs and SCADA servers are connected through industrial Ethernet. So Modbus is not just one cable type. It is a language that can travel through different media. In a boiler system, a PLC may request steam pressure from a transmitter at device address 5. The transmitter replies, and the PLC uses that value to control the firing rate. Modbus became popular because it is simple, flexible, and supported by thousands of devices. However, it lacks built-in security. Always use firewalls and network segmentation for protection. Now let us move to Profibus, the fast and reliable field bus for high-speed factories. Profibus was created in 1989 as an international standard to simplify field device connectivity. Instead of hundreds of wires, many devices could communicate over one single bus cable. Profibus DP is used in factory automation, connecting PLCs to robots, drives, and remote I/O. Profibus PA is designed for process industries, carrying both power and data to field instruments. Profibus uses a disciplined master-slave structure where the PLC polls every device in a fast cycle. Profibus DP supports high-speed data rates up to 12 megabits per second over RS-485. One Profibus network can act as the digital nervous system for an entire automated production line. While Modbus is simple and universal, Profibus is powerful and structured for high-speed control. Modbus and Profibus are the foundations of Industry 4.0, turning field signals into usable data. Together, they keep modern factories alive, transforming isolated machines into a connected brain.